So, we need to talk a little bit more about theoretical yield. This is where you should be on your notes. This is right after the limiting reactant stuff. Whoops. Oh, that's not good. So you should make sure you study your quizzes a little bit more. I'm going to try and get you guys a study guide by Monday so that you have it to look at all week next week. Thursday. Thursday's the test. All right. So we've already talked about this theoretical yield thing, okay? At this point, we have basically assumed that we have done our reactions perfectly in the lab. No spilling, nothing left on the filter paper, nothing left in a beaker, okay? It's perfect. Now, even if we did our reactions pretty much perfect, you're still not going to get 100% yield because the universe itself is not perfect. So you're just never going to get 100%, all right? So theoretical yield, that's the maximum quantity that a reaction could make if everything works perfectly. You are never going to get 100%. You're just not, okay? Let's do a problem. Wait, did we already do this? Okay, sorry. We already talked about theoretical yield, but it's good to review that. Okay, and we talked about the excess stuff. That's still limiting reactant. Okay, here we go. Okay, so again, equations are telling you what should happen, but they're not telling you what's actually going to happen. Okay? The actual yield is going to tell you how much you actually get. Actual, that's how much you actually get. Makes sense, right? So theoretical yield is, in theory, on paper, this is how much we should be able to make. The actual yield is, okay, I've just done this in a lab, and these two numbers don't quite match up, right? So that's the mass of the product that is actually formed, and it's always going to be less than the theoretical. And it's always going to be given to you in the problem, because guess what? When you're sitting here doing a paper and pencil problem, you can't stop everything, do a lab real quick to find your actual yield, and then come back to the problem. Now, we are going to do that in the lab that we do at the beginning of next week, okay? So you will get a chance to actually figure out the actual yield, okay, and then compare that to the theoretical. But on a test, the actual yield has to be given to you, all right? And the actual yield can be tricky to identify, but I'll show you in a couple of problems how you can pick it out. And then from the actual yield versus the theoretical yield, you can calculate percent yield, okay? So really all we're doing here is we're tacking one extra step onto the end of a, what's that?
You divide the actual yield in
actual divided by theoretical, yep. So you calculate the theoretical yield first. That's always your first step, okay? Which, that's exactly what we have been doing, right? So in the limiting reactant problems, all you've been doing is calculating theoretical yield of a product, all right? So that's the first step. You're going to do a gram-to-gram conversion here. The percent yield problems are always going to be in grams, okay? And then your percent yield is going to be a ratio relating the actual yield to the theoretical yield. So the equation is actual divided by theoretical times 100. Do you guys have that on your paper already? Okay. Actual divided by theoretical times 100, okay? So again, your percent yield is always going to be less than 100%. If you get, that changes it to a percentage. Because if you take actual divided by theoretical, that's going to give you some decimal number. It'll give you like 0.8 or 0.9 or something. Multiply that by 100, it gives you 90%, right? Yeah, you just move the decimal place over to the right. Let's do a problem. That wasn't excited enough. That's 3 exclamation points. I'm sorry. Let's do a problem.
Yeah.
Okay. Yeah, sorry. No one's going to see that on the arm swing on the video, but that's really what made that just then. Okay. So here is a rather long problem here. Determine the limiting reactant, theoretical yield, and the percent yield if 14 grams of nitrogen are mixed with 9 grams of hydrogen, and 16.1 grams of ammonia are actually produced. What do you think that 16.1 is?
For actual. The actual yield.
So 16.1 grams of ammonia are actually produced. That's probably the actual yield, right? Okay? So there you go. I know it says it's tricky to identify sometimes, and this one is pretty easy, right? You may not have the word actually in there, okay? But this, it's going to tell you in a lab or in the experiment, this is how much was made, okay? If you see an experiment or a number that's tied to the experiment itself, that's your actual yield, all right? Okay, so 14 grams of nitrogen mixed with 9 grams of hydrogen, and we're making ammonia. Well, what's the first thing we need here? Balanced equation. Is that on your worksheet? Yeah. Okay. So the equation right there, N2 plus 3H2 yields 2NH3. Okay, nitrogen plus hydrogen gives you ammonia. All right, from there, there's going to be 3 parts to this problem, okay? Nope. I thought maybe it was going to give me part 1, part 2, and part 3. What's the first part of this problem? We already talked about it.
Moles.
Well, the first, here, let me go back. Yeah, there we go. Determine the limiting reactant, then the theoretical yield, then the percent yield. Those are the 3 parts of the problem, right? Okay? Yeah, essentially. The way we're calculating it, once you've found the limiting reactant, you're going to have the theoretical yield at that point, okay? All right, so 14 grams of nitrogen, 9 grams of hydrogen. So 14.0 grams of N2 and 9.0 grams of H2. I didn't just mix those up, did I? I forget things very quickly. Okay. So then,
1 mole over.
we're going to go from grams of N2 to moles of N2. 28.014, because you have to multiply the molar mass of nitrogen by 2. And we're going to go from moles of N2 to what? Moles of NH3. Why NH3? Yeah, why are we going to moles of NH3? That's the only product here, right? Now, let's say that this wasn't the only product. So maybe, what if we had, and again, just go with me, this is not a good chemical equation, but let's say that we had that, right? Well, okay, and here's where you have to be careful. What are they giving you, what did they actually determine in the lab? The ammonia, right? Okay? So unless you want to do extra work, you probably should go to the NH3 if that's the one they're giving you the actual yield for. Does that make sense? So look at the one they're giving you the actual yield for and make sure you work your way to that one if there's more than one product. But here we don't have to worry about it. There's only one product. Okay. So the mole ratio, while we're on this screen, for N2 to NH3 is a 1 to 2 ratio. All right, 1 mole of N2, 2 moles of NH3. Then we need to figure out the mass of our NH3. 17.0307. Okay, that sounds right. So there's that one, okay? And then the same thing with the hydrogen. Grams of H2 to moles of H2. Is it 2.0158, I think? And then we're going to go from moles of H2 to moles of NH3. Okay. Now again, I know there's only one product here, but what I did see on a couple of quizzes that I forgot to talk about, some of you worked your way to one of the products the first time you did it, and then you figured out the other product the second time. Okay, that doesn't help you. You need to figure out the same product both times. Yes, ma'am.
So the first part, versus the grams and 3, what is the number?
17.0307. Okay, so then the mole ratio between the NH3 and the H2 is 2 to 3. And we're going to go from moles of NH3 to grams of NH3, which we already did. So we've already got that number. All right, so then you just work both of those out. Is there? Okay, so this one's going to be 17.0, right? And 9. And 50.7? No, 51. 51.
How do they get that big of a difference when the numbers are so close? Like 14 and 9 are close.
Yeah, it's the molar masses. Here you're dividing by 28, and here you're only dividing by 2, right? So that makes a big difference. Okay, so our clear limiting reactant here is nitrogen. Okay, there's our limiting reactant. Step 1, done. Step 2, basically done, because what is our theoretical yield? It's the smallest of the two, right? Okay, so 17.0 grams. So limiting reactant is into our theoretical yield, I'm just going to call that TY, is 17.0 grams of NH3, of the ammonia, right? Okay. When we're talking about yield, we're always talking about the product. How much of the product can we make? All right? So then, for our percent yield, which is just one extra step that you tack on the end here, this is our theoretical yield. This is how much, in theory, we should be able to make. Now look back over here. We actually made 16.1 grams, right? Thank you. Okay, so you take your actual 16.1 divided by the theoretical, which is 17.0, times that by 100, and that's going to give you your percentage. And that's it. How do you know to times by 100? It's a percentage. So if you take 16.1 divided by 17, you're going to get a decimal, 0.947, and some other numbers. You want to times that by 100 so you get a percentage instead, which is going to give you, 2 sig figs. But, well, wait a second. Yeah, we're going to do 3 because we've got 3 sig figs up here, right? And we've got 3 sig figs in the actual yield they gave us, so it's going to be 94.7%. Whoops. Yes, ma'am.
What if, it was 16 grams, then you had 17.0?
Then you'd round it to 2. If it was 16 on top, just 16 on top, and 17.0 on the bottom, you round to the lowest number of sig figs. Yep. So it would be 2 sig figs.
And then what were we finding yesterday?
The excess reactant? Yeah, that's the amount of excess. Now, you don't have to worry about percent yield for that. That's a different question, okay? So these percent yield problems, they're all going to pretty much be exactly like this. There's really not a lot of variation in the percent yield problems, okay? So that's basically what you do. Yes, sir?
How do you know when to subtract the limit?
Okay, so the subtraction thing from the quiz, if they ask you how many grams of the excess are left over, if they ask you that question, how many grams of the excess are left, then you're going to do that subtraction, okay? If they're asking you what's the percent yield, that's this process, okay? We're going to have some time at the beginning of next week to review all the different types of stoichiometry problems you might see, okay? So I think hopefully by the time you get to the test, you'll be able to sort them all out and know just by looking at the problem, okay, here's the type of problem it is, here's what I need to do. All right? Whoops. Of course. Let me erase all this so that you can actually see the screen. There's just some writing. Isn't there? Or is that it on yours? Oh, you have another example. Okay. Yeah, there are. I think I'm going to give you a more detailed list than that. Okay. So actual yields can only be determined experimentally, but if we are given the percent yield, we could estimate the actual yield. So this is kind of a working in reverse type of thing. So how many grams of CH3COOC5H11? Oh, that's just not nice. I do not know off the top of my head what that's called. It's going to be a carboxylic acid of some sort. No, that's not. That's a, is that a ketone? This oxygen is double bonded to this carbon and is connected to another oxygen on one side and a carbon on the other side. I always forget I think that's a ketone, I think.
Wow.
It's a big log organic molecule. If the COO was on the end, the COOH, then it would be a carboxylic acid. But I'm gonna have to look into that. Anyway, it's an organic molecule, a big one. So how many grams of that should form if 4,808 grams are theoretically possible, and the percent yield for the reaction is 80.5? Okay, you should hope for this type of problem on your test, because the formula for percent yield is actual over theoretical times 100. Just plug stuff in and solve for x. Okay, these are nice and easy. So what is our percent yield here? 80.5, right? And that's equal to the actual over the theoretical. Now, what do we know here? Do we know the actual or the theoretical? Yeah, theoretically possible. That's kind of a big clue, right?
Really do that on the test.
So the actual divided by the theoretical, which is 4808, times 100, right? First thing I think I would do is just divide both sides by 100 to get rid of that weird times 100 on the end there. So then what you end up with is 0.805 is equal to your actual over 4808.
So now you just
You guys understand what I did there?
No.
I just divided both sides by 100, right?
yeah,
If I divide both sides by 100,
Same here.
then this cancels out, right? What's that? I just divided both sides by 100 to get rid of it. Well, I mean, you could put it down here, but I'm just putting it off to the side, right? Yes. Okay, so once you got this, all you have to do is multiply both sides by the 4808. That'll get rid of the 4808 on the bottom. Say it again. 3,870? Okay. So 3,870, and that's the right number of sig figs, right? Well, wait a second. Yeah, that's right, 3,870 without a point, okay, because there are 3 sig figs in your percentage.
Look at like the top. You can see the 0.8.5.
What is it? It's an acetate.
It has the
Oh, so it is a carboxylic acid. They just fooled me with the way that they wrote it. Oh, okay, it's an ester. I didn't think esters were named as acetate. Okay. I always get the ketones and the esters mixed up. I think a ketone... Oh, the ketone is just the oxygen sandwiched in between the 2 carbons? Okay, gotcha. Yeah, you don't need to know that in first year chemistry. You don't need to know it in AP chemistry anymore. They took it out. So yeah, you're good. All right. So 3,870 is your answer on that one. That was nice and easy. No stoichiometry involved in that one, right? So that's why I'm saying that's the kind of problem you hope is on the test. Probably something like that. Whoops. Well, I mean, there's a big hint here, right? Theoretically. So it's going to be fairly clear. All right. So that's it. We got some practice problems to do on this. Actually, the practice problems that you're going to do are the ones that I've already given you. We've done 1 through 18. You probably haven't done all of those. They take a really long time. But now we're going to do 19 through, is it 27? 27, 19 through 27, okay? And the rest of them are percent yield problems. Some of them require you to figure out what the limiting reactant is. Some of them, they tell you what the limiting reactant is. So that makes it quite a bit easier, okay? And we have an answer key for that, so go ahead and get started on that now. You've got about 20 minutes that you can work on this.